All right, so we're going to go through the next couple questions here in this video. So number 13, they give us this graph of what appears to be a parabola, and then it's a matching question where they give us several different functions here, f of x plus 2, f of x plus 2, 2f of x, f of 2x, 2f of x plus 2, 2f of x plus 2. And so my advice is just we'll think about what each of these things does. So we're adding 2 outside the function, so that's going to add 2 to every single output, which the effect on the graph would be to shift it up 2. So my original graph, a couple things to notice there. One, it has a vertex at 1, -1, x-intercepts at 2, 0, 0, 0, which is also the y-intercept. And it seems to follow that regular parabola pattern of up 1 over 1, or from the vertex over 2 up 4. So it doesn't seem to be stretched or compressed at all, just shifted from my original parabola here. And so now I'm going to take this parabola that's already been shifted and I'm going to do a couple more transformations to it. So if I were to shift this up 2, it's obviously just going to move my vertex up 2 and my x-intercepts also up 2. So I'm just looking for something that has been shifted up 2. And I think yours will be scrambled around a little bit when you look at the choices. But still, you're just looking for one where first thing I would check is the vertex at 1, +1 instead of 1, -1. And so it looks like that could be this one here. No, 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 no. Let's pull it over here to see all these choices. Yeah, that's literally the only one it could be, just by looking at that vertex. So let's kind of draw a line here. So this one goes here. Now the next one is going to be shifted left 2. It's inside the parentheses. It's affecting the x values. It has the opposite effect on the graph of what it would look like. So I'm going to take my x-intercept, my vertex, and I need to slide them over to the left. So this is going to stay as -1 for the y, but it's going to move to -1 for the x. This is going to move to -2, and this is going to move to the origin. Not going to repeat that one. No, that's been moved down. Hey, I think this is it. My vertex went over to my x-intercepts went over the right way. It doesn't look like it's been stretched or compressed at all. So I think we're good there with that one. Two f of x. That's going to take the outputs, the y values, because that 2 is on the outside, and it's going to multiply them by 2. That's going to give me a vertical stretch. And one thing that's always nice to remember with a vertical stretch is if the y-coordinate is already 0, multiplying that by 2 doesn't change anything. So you can think about it as really everything's being pulled away from the x-axis. But anything that's on the x-axis doesn't move at all. So I'm looking for my x-intercepts to be the same, but everything else to be just pulled. So my vertex should go down here to -2. These 2 x-intercepts will stay, but say my next point here, which is at 1, 2, 3, looks to be it's at 3, 3. That's going to be at 3, 9. This one that's at -1, 3 would be at -1, 9. So it's going to be a lot skinnier graph. But it's not, sorry, I said skinnier, but it's going to be a lot taller graph, but it has not been compressed horizontally, so it's not actually skinnier. So let's see here. Where's one that looks like, okay, so I need my first thing I'm looking for is my vertex pulled down a little bit. And so when I look at that, I see this one. This looks like my vertex has been pulled down, but it actually looks like it's gone too far. You know, it's supposed to be just multiplying the y by 2, and so that would be from -1 to -2, but it went too far. No, it's moved over to the right, moved to the left, and smashed. Here's my -2. My x-intercepts are the same. When I go over to 1, 2, 3, it's really tall. Yeah, I think it's this one. So I'm just kind of going through and saying, okay, what should this do? Which one maybe looks like it maybe fits that a little bit here. Okay, now 2 on the inside, that's instead of multiplying the x's by 2, we're going to divide the x's by 2, but the y's will stay the same. So it's going to be smashed skinnier, but without getting any taller. So when I look here, I'm thinking it is this one here. Because my y on my vertex did not go down or up at all. It's still at -1, but my x was at +1. Now it's at a half. This also, I had an x-intercept of 2. Now it's at 1. It's been cut in half. The x-intercept of 0 stayed at 0 because half of 0 is 0. So that appears to be the one I'm looking for here. Okay, now in these next two, we're doing 2 transformations at a time. So with y transformations, when it's outside the function, you're going to multiply the y's by 2 and then add 2 to that new value. So thinking about my vertex, multiply it by 2, now it's at -2. Add 2 to it, and now we're at 0. So I'm looking for something with a vertex of 1, 0. And that might be all I need. You know, sometimes in a multiple choice situation like this, there's only one that could possibly work. And that is, in fact, the case here. This is the only one with the correct vertex. And then for the last one, you do the opposite order of operations. So I'm going to move it left 2, and then I'm going to divide it by 2. So thinking about that, I'm going to move left 2. Oops. I'm going to move left 2, 1, 2, and then cut that in half. So I need a vertex of -1/2. Let's see if we can find that somewhere here. Only one has that correct vertex, this one here. And sometimes that's a little trickier. You might have to check a few other points to see if it works, but in this case, I think it was really just the vertex that we had to check for all of these ones. For number 14, it's just the table of trig values. You can just check all those values, check those conversions between degrees and radians. I'm not going to go through that all here. If, however, you're stuck, if you're like, hey, I checked the values, I have all these numbers, and I don't know why this is whatever it is, please send me a Schoology message. I'm totally happy to walk through that if you need it. Okay. Next problem. So this is, again, matching in graphs. And in this problem, instead of just starting with the same graph every single time and transforming it different ways, we have some different graphs that we're going to look at. So we're going to look at a sine graph that's transformed, a tangent, an exponential, and a logarithmic, all of which have been transformed. So on one hand, it's a little bit easier because I can sort of say, okay, well, I'm looking for a sine graph. I can get rid of everything that's not a sine graph and then come back and look at it. So for my sine graph, it could be this one, this one, this one, and nothing over there. So I know that normally sine should pass through the origin, but now I'm shifting it to the right by pi/4. So when I look at my sine graph, it should pass right through the origin, but I need to shift it to the right pi/4. Well, this actually appears to be correct. Now, it's hard for me to see. The scale here is by 10, so did I actually go to the right pi/4? Well, hard to know exactly if that's pi/4, but from the other ones, I can see that this isn't right at all, because that origin point where the sine graph passes through the origin, it's supposed to be going up. It has a positive slope when it passes through the origin. If I'm going to the right, the next positive slope going through the origin is way over here. That's almost halfway to 10. And pi/4 is not halfway to 10. It's, about 3/4. So that's definitely out. Same over here. Now we're even farther. And you could say, ooh, but what about this positive slope? Well, you went to the left. You're supposed to go to the right. So this little tiny shift to the right, positive slope, just a little bit to the right of 0, that's got to be the one. So this is that one. Now, for tangent, again, I can go through and say, okay, well, which ones could be tangent? And then let's worry about the transformation. And you should know these basic shapes. I mean, you need to know these basic shapes. It's one of the things that we have to know for calculus, which is why it's on your readiness for calculus assessment. So with tangent, here's a tangent, here's a tangent. Whoops. Try to follow that, huh? Here's a tangent. And so it's supposed to be negative tangent. So that negative, it's outside the function. So it's going to take all the y values and just change their sign. And so when I look at that, between the two of these, I'm thinking about, okay, well, what should the regular tangent look like? And again, just like with sine, I know that tangent is supposed to go through the origin. Changing the sign is not going to make it not go through the origin. It's going to make it go through the origin in the opposite direction. Regularly, tangent would go like this. Start on the bottom left and go up, just like an x cubed. But make it negative, and just like an x cubed, you flip it. So it's that one. This one does not go through the origin. It can't be tangent. Two to the x minus 1. Well, again, let's think about anything that's exponential here. So let's see. Where do we see something exponential? This looks exponential. This looks exponential. This. Let's see about this one. Even this one, possibly. And the tricky thing here is that deciding between an exponential and a logarithm is tricky because they're inverses of each other. They have the same shape. They just go in the opposite direction. So when we're talking about transforming those things, well, hard to know. Is that an exponential or is it a transformed logarithm? So we got to go through it a little more carefully, and that's fine. So if we think about what this minus 1 here would do, all it's going to do is take my exponential and shift it down 1. Now, if I think about my normal exponential, I know that anything to the 0, any non-zero to the 0, so 2 to the 0 would be 1. And then I shift it down 1, so it would have an x-intercept right through the origin. And I also know that as I go to the left, it should just, without the minus 1, this graph should have a horizontal asymptote, an end behavior that as x goes to negative infinity, the y's go to 0. So now this is just going to drop this down to a horizontal asymptote of negative 1. So I'm looking for an exponential growth that's been shifted down 1. Horizontal asymptote of negative 1, y-intercept through the origin. No, yes, that one. That one has a horizontal asymptote of negative 1 and a y-intercept of the origin. Now for my natural log, again, you should know what the basic shape of natural log looks like. It's something we need to know for calculus. But remember, there is not an addition and subtraction section on this readiness test because that is something that you should not need to review. The concepts on this test are things you need to know, but also things that you probably don't know well enough that you don't need to review them at all. That's the whole idea here, is that let's go over all the stuff that's maybe a little bit tricky, give you another chance to review that, give you another chance to ask questions about that before we need this for calculus. So the basic shape of the logarithm graph is just the exponential graph reflected over the line y equals x. So it should have an x-intercept of 1, 0, just like our exponential has a y-intercept of 0, 1. And we have a vertical asymptote along the negative y-axis, just like our exponential has a horizontal asymptote along the negative x-axis. And so what does this negative in here do? Well, it changes the sign on all of the x's, which reflects my graph over the y-axis. So I'm looking for a graph that has been flipped over this way. And that appears to be this one. Oops, I keep forgetting to get rid of my move tool there. I didn't think it was this one at first because of where the x-intercept is here. But we're going by 2, 4, 6, 8, 10, so that is in the right spot. I had to double check there. Okay. So nice review there of some of your transformations as well as some basic shapes of graphs that we want to make sure we know. All right.